Hello my dear young scientists. In the previous section, we have seen the formation of salts during various reactions. Now let us understand more about their preparation, properties and uses. Let us do some activity. You already have learnt in grade 9 about writing formulas. So I am giving you some names of the salts and you have to provide me the formulas of this by knowing what is the cation and what is the anion. Okay, so let's get started. The first one is potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate and ammonium chloride. Now you have to identify the acid and the base from which these salts may be produced. The sodium chloride, potassium nitrate, aluminium chloride, these salts, you can see that sodium chloride, when we say this, it has been prepared from the base sodium hydroxide and HCl. Now this is your task. You have to find for yourself that what is the acid and the base from which these salts are prepared. You have to tabulate your results, your findings in a proper table. Okay? Now because we have learnt about the pH of acids and bases, do salts also have some pH? Yes, let us check it. The salts of a strong acid and a strong base are neutral and they will have a pH value of 7 because there is a complete neutralization between the acid and the base. I am not doing this experiment for you now. You already have this expertise and you have to do it and tabulate. Okay? Similarly, the salt of a strong acid and a weak base would be acidic in nature and the pH value of such salts would be less than 7. Similarly, if I take a strong base and a weak acid, the salt would be basic in nature and the pH value would be more than 7. This is your task. You have to find which is a strong acid, which is a strong base. So this is an indication, isn't it? So if I find that aluminium chloride salt gives a pH which is less than 7, that means it's a salt of a weak base, aluminium hydroxide, and a strong acid, HCl. So in this manner, you would be able to say which acids are strong and which bases are strong, isn't it? So the table is there in front of you on the screen. You have to find the pH of the salts given in the table and also say which acid and which base have been used to produce these salts. Now that we know that salts can also be acidic, basic or neutral, we are all set to learn a little more about salts and various preparations. And when I say, my dear friends, the word salt, the first thing that comes to our mind is common salt, NaCl, the salt that we use in our food. And do you know about how this salt is related to our history, the freedom struggle? You must have studied about Dandi March in your history classes, isn't it? So recall that what is the importance of salt in our struggle for freedom. Let us come to the chemistry of common salt. Common salt is also a raw material for various chemicals. The common salt, which is obtained from the seawater, is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, washing soda, bleaching powder and many more. Let us see how one substance is used to make all these different substances. First of all, we will see the preparation of sodium hydroxide. For this we need a concentrated solution of sodium chloride. The concentrated aqueous solution of sodium chloride is called as brine. And when electricity is passed through this solution, it decomposes to form sodium hydroxide. The process is called chlor-alkali process because the products formed from the chlor-alkali process are chlorine and sodium hydroxide, which is alkaline in nature. The reaction taking place in the cell is sodium chloride aqueous, and because it is aqueous, there is water. When electricity passes through it, it gives you NaOH aqueous, chlorine gas and hydrogen gas. So, in the chlor-alkali process, the chlorine gas is given off at the anode, and what happens at anode? It is always the oxidation, okay? And the hydrogen gas is given off at the cathode where reduction takes place. The sodium hydroxide solution is formed near the cathode at the base of the container. The three products produced in this process are all very useful. For example, the hydrogen gas produced can be used as a fuel. Hydrogen is a very clean fuel. It can also be used to produce margarine, ammonia for fertilizers. The chlorine gas produced is used for water treatment of the swimming pools, PVC and disinfectants. CFCs and pesticides are also produced using chlorine gas. The sodium hydroxide produced is used for degreasing metals, production of soaps and detergents, paper making, artificial fibers, etc. Now, let us learn more about some specific products which can be produced from these three basic products from sodium chloride. The first product that we are going to study about is bleaching powder. As the name suggests, it is used for removal of color. The bleaching powder is produced by the action of chlorine gas, which was produced in the chlor-alkali process on the dry slaked lime, that is calcium hydroxide. The bleaching powder is represented as calcium oxychloride, that is CaOCl2, which is produced by the chemical reaction as calcium hydroxide plus chlorine gives calcium oxychloride, CaOCl2 and water. The bleaching powder has got various uses besides decolorizing. It is used for bleaching of cotton and linen in the textile industry. It is used for bleaching of wood pulp in the paper factories and for bleaching of washed clothes in the laundry. It is also used as an oxidizing agent in many chemical industries and also for a disinfectant for drinking water to make it germ free. The next compound that we will learn, which can be produced from sodium chloride, is baking soda. The soda which is commonly used in the kitchen for making tasty crispy pakoras, it is the baking soda. Sometimes it is also added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate, written as NaHCO3. It is produced using sodium chloride as one of the raw materials, and the reaction is sodium chloride plus water plus carbon dioxide and ammonia, giving us ammonium chloride and sodium hydrogen carbonate. Now there is a task for you. You have learned how to check the pH of sodium hydrogen carbonate. Please find the pH and tell me what is the nature of the base and the acid from which sodium hydrogen carbonate has been produced. Can you now correlate why sodium hydrogen carbonate can be used to neutralize an acid? It is a mild non-corrosive base. The following reaction takes place when sodium hydrogen carbonate is heated. We should know that why we use sodium hydrogen carbonate in making crispy pakoras. isn't it? So during cooking, what happens is that when sodium hydrogen carbonate is heated, it releases sodium carbonate, water and carbon dioxide. And this carbon dioxide is responsible for making the things fluffy. The sodium hydrogen carbonate has got various uses in the household. And the uses of sodium hydrogen carbonate, besides the cooking that we just talked about, is for making of baking powder. My dear students, you have to know the difference between baking soda and baking powder. Baking soda is only sodium hydrogen carbonate, and from baking soda we can produce baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid or citric acid. When baking powder is heated or mixed in water, the following reaction takes place. Sodium hydrogen carbonate plus hydrogen ions. And from where do I get these hydrogen ions? We just said, from any edible acid like tartaric acid or citric acid. When these two are mixed together, they will produce carbon dioxide, water and the sodium salt of the acid. And this carbon dioxide produced during the reaction causes the breads or cakes to rise and make them soft and spongy. The sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes the excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. Now this is your task. You have to prepare your own soda acid fire extinguisher at home. Okay? The next compound that we are going to study about is washing soda, Na2CO3.10H2O. Washing soda is also produced from NaCl, the common salt, the salt which is produced from the seawater. So from seawater to common salt, and now we are coming to washing soda. You have seen in the previous reaction that sodium carbonate can be obtained by heating of baking soda. The recrystallization of sodium carbonate. When I say sodium carbonate, it is only Na2CO3. So recrystallization of sodium carbonate gives us washing soda. Washing soda is also a basic salt. We can write the reaction as Na2CO3 plus 10H2O giving us Na2CO3.10H2O. So the Na2CO3 solid is just sodium carbonate. But when we write as Na2CO3.10H2O, it is the crystallized sodium carbonate, which is the washing soda. The uses of washing soda are, it is also used in the manufacture of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is also used for removing permanent hardness of water. So my dear friends, we have learned till now that we can appreciate how one compound can be converted to another by carrying out chemical reactions. We also know now how to write chemical reactions. For example, starting from the common salt, we learned preparation for various other useful substances. I am sure now you can explain the preparation and manufacture for some important compounds of sodium like bleaching powder, baking soda and washing soda. So my dear young scientists, when we said that the washing soda that we use at home for washing is Na2CO3.10H2O, and the 10H2O are the molecules of water of crystallization. At home, when you see the washing soda, is it wet or is it dry? Sure, you must be saying that it is dry. Are the crystals of salt really dry? Where is this water? Let us do some activity and check this out. For this purpose, we will take copper sulfate crystals. The copper sulfate crystals, which seem to be dry, contain water of crystallization. And when we heat the crystals, the water is removed and the salt turns white. So, are the crystals of salts really dry? Let us check this out with copper sulfate. Copper sulfate, which is a bright blue aqua colored crystal, we will do an experiment with this and try to find out answers for this. We say that copper sulfate crystals have a formula CuSO4.5H2O, and these 5H2O, that is 5 molecules of water, are the water of crystallization. So, I will take a dry test tube and transfer some amount of this crystalline copper sulfate to the test tube. And now, let us heat it and see what happens. On heating these aqua blue copper sulfate crystals, I am sure you people can see that there are water droplets that are accumulating on the walls of the test tube. Be careful not to touch it directly, it is hot. And these water droplets, from where have they come? Obviously, these are being released from the copper sulfate crystalline. That means the hydrated copper sulfate is now releasing these trapped 5 molecules of water that each copper sulfate unit had with it. And slowly, can you see the color change? Let me transfer this white powder that has formed due to release of water from the copper sulfate crystals onto another watch glass so that you can compare the color of the two. And this has to be done after cooling because the test tube is very hot. Please compare the colors. The blue, bright, crystalline copper sulfate and the white colored anhydrous copper sulfate, which does not have the water molecules in it. Let us put some water droplets into it, that means moisten it, because we said that this is hydrated copper sulfate and this is anhydrous copper sulfate. So, if I put some water and hydrate it, will I get the color back? This is for us to see. Let us check it. So, we will take some water and just put few drops, just 1 or 2 drops, and just see, just with 1 drop the color has quickly changed to blue. Is that magic? No, it is chemistry, because a hydrated copper sulfate is blue and anhydrous is white. When we put water back, it becomes hydrated and the color is restored. So, we have now studied about 2 salts which possess water of crystallization. One was washing soda, that is Na2CO3 10H2O. Another was copper sulfate, that is copper sulfate dot 5H2O. Another salt which possesses water of crystallization is gypsum. Gypsum has 2 molecules of water as water of crystallization, and its formula is CaSO4 dot twice H2O. That means calcium sulfate twice H2O. On heating gypsum, calcium sulfate dot twice H2O at 373 Kelvin, it loses its water molecules and becomes calcium sulfate hemihydrate, that is CaSO4 dot half H2O. Hemi, you know about what is the meaning, hemisphere, half, okay. So, this CaSO4 dot half H2O is called plaster of Paris. the substance which doctors use as plaster for supporting the fractured bones in the right position. Plaster of Paris is a white powder, and on mixing with water, it changes back to gypsum, giving us a hard, solid mass. Let us write the reaction. Calcium sulfate dot half H2O plus 1.5 molecule of water gives us calcium sulfate dot twice H2O. Note that only half a molecule of water is shown to be attached as water of crystallization with calcium sulfate. Is it possible to have only half a molecule of water? How do you get it? This is a quiz for you. Okay, I'll give you the answer. One molecule of water is being shared by two molecules of calcium sulfate together. So, each one of them gets only half a molecule of water as the formula unit. So, plaster of Paris is used for making toys, materials for decoration and for making surfaces smooth. You must have seen its working. Try to find out why is calcium sulfate hemihydrate called plaster of Paris, because I told you that as a little scientist you should always ask questions, and it is not only in asking questions, you also have to invest some time in finding answers to those questions. So my dear young scientists, in this chapter acid, bases and salt, we learned various techniques of classifying acids, bases and salts. We also learned how to plan our activities, how to design an experiment to quench a thirst of asking questions. We understood how to find the difference between a strong acid and a weak acid, a strong base and a weak base by using pH paper. You also learned that how a salt which is formed by neutralization between an acid and a base can also be either acidic or basic, because if the acid is strong, the salt is going to be acidic, and in case the base used is strong, the salt formed would be little basic in nature. We learned how to relate the various concepts of acids, bases, salts and pH to our day-to-day life. We know how to cure our stomach ache when we have overeaten. We know how to bake our cakes and make them fluffy. We know how to use plaster of Paris to make various toys and models. So, as young scientists, the first thing is to ask questions. Ask questions about various phenomena that happening around you. Then you have to observe and then collect data. We also learned how to collate our data and tabulate it. While collecting data, we have to be really very careful that to report only the true findings, because if there is something that is waving away from the expected result, that is also an experimentation. Okay? So, collect your data, tabulate it, tabulate only the correct data and then analyze. That is another attribute of a scientist. You have to analyze the data and then come to a conclusion. And while planning your experiments to find answers, see to it that you work in teams, because we know that unity has power. Come together, be inclusive, take along people, take along your friends who have some special needs. That is the spirit to work and move ahead. And in all these experiments, we have to remember to take care of our surroundings. We have to keep our surroundings clean and take care of our environment. We should not be using too much of chemicals and throwing them, because it will harm our environment. So, my dear young scientists, Be involved. Be involved in the quest of asking questions and seeking answers. Finding ways to do experiments, and always move ahead with a smile on your face and a twinkle in your eyes. That's what we need for our country to rise and shine.